Alright, we just saw Newton's method here, and this is then the update rule. The update rule uses a second order derivative, and the Hessian, especially the inverse of the Hessian, can be quite expensive computationally, but Newton is faster and there is no alpha. So there's no hyperparameter to choose in this case. Yeah? So typically this would be used when the number of features is less than 1,000. Yeah? And all of this has to do with the inverse of the Hessian here. Alright, let's look at a few more methods to have gradient descent work better. Yeah? In the full batch gradient descent, this was the cost function that we derived. Yeah? And let's put here I, because this is a formula per sample. You need some I is 1 to m. And this could be quite heavy to calculate, because you gotta update all these weights simultaneously. And you know, in our housing price exercise, m was 6. 6 is peanuts. Yeah? But imagine that you have 300 million training samples. That means I goes from 1 to 300 million, no? No? So this m here is 300 million. And it's quite heavy to calculate. Now, what is the idea? So that was, I would say, that was full batch gradient descent, you know? It's all we have looked at for the time being. Now, stochastic gradient descent, what does it do? Well, it's quite simple. The idea is the following. You shuffle the data set. Shuffle data set. And with data set I mean the training data. Yeah. And then you execute gradient descent on one sample. Yes, one sample out of the 300 million, and then you update. And this you repeat. No? Remember the contour plots. So the contour plots look like this a little bit. Yeah. And remember with gradient descent, we started here, and we then converged to that minimum. No? In quite a smooth way. Well, with stochastic gradient descent, you're gonna be a bit all over the place, because you're gonna update only one feature at a time. Yeah. So in red, this would mean that you're gonna be a little bit all over. Yeah? But eventually you will converge, or not totally converge, because you probably dance around the minimum. But that's not such a big issue. Yeah? It will just be very noisy. Stochastic gradient descent is very noisy. Okay, but then and we will not really use stochastic gradient descent. Yeah. The next option is mini batch. Mini batch stochastic gradient descent. And basically it's between stochastic and full batch. That's why we call it mini batch. So you process training data, in batches. Yeah? And the batches are typically powers of 2. So 64, 128, 256, 512, and so on. Yeah. You as a data scientist, you will need to choose the size of your mini batch. So the mini batch, the size of the mini batch is what we call again a hyper parameter. Like alpha, the learning rate is a hyperparameter. Yeah. What I can say is we will use this one quite a lot. This is the go-to method for large data sets. Yeah. Mini batch stochastic gradient descent is frequently used, especially when we go to deep learning. Where will mini batch be? Well, it will be a bit more noisy than the full batch. Remember, the full batch is the blue line here and goes quite straight. And it will be a bit less noisy than the stochastic one. So I would say go a bit like that. Yeah? Okay, so this we will not use. Mini batch we will use often.